Good morning, children. I am Anmol PGT Physics, Mount Litra Z School Jhansi. Children, in our previous videos, we have discussed about a new chapter which is current electricity, and I explained you what exactly current is and what is the direction of current and why it is known as scalar quantity. Also, we have discussed about how current is formed, that is, we discussed about drift velocity and thermal velocity as well. Now today we are going to derive an expression, a relationship between drift velocity and current, because drift velocity is the velocity which is responsible for developing current. Hence we are going to derive a relationship between current and drift velocity, and later on we will discuss a few more topics related to current and voltage and other physical quantities which are a part of current electricity. So children, you can see here I have written relation between drift velocity and current. The expression for current is I is equal to q by t, and since q is equal to plus minus ne, that is quantization of charge, here we are taking electrons, hence q is taken as q is equal to minus ne. Now for the entire wire, the charge would be q is equal to minus ne into v, where v is volume, and we can even write volume as area into length. So the final charge for the entire wire would become q is equal to minus ne L into A. Okay, now we can use our expression which is I is equal to q by t, and in this expression we'll put the value of q. So finally we'll get I is equal to minus ne L into A by t. Okay, but as I have circled here, you can see L by t becomes displacement upon time, which is actually velocity. So I have written drift velocity Vd instead of that. So I is equal to minus NEA Vd. This is the expression or relationship between current and drift velocity. Now the next topic that we are going to discuss is current mobility. Current mobility is actually denoted by mu. Now what do you understand by mobility? Mobility actually signifies that how easily a charge can move in a wire. Okay, so here we are going to define it in a different way with the help of its expression. Current mobility is defined as drift velocity per unit electric field, that is mu is equal to Vd by E. As I have written over here, you can see it very clearly. If we are going to drive the SI unit of that, so for drift velocity we'll write meter per second, and for electric field it would be Newton per coulomb. So hence the final unit which you will get is coulomb meter per Newton per second. Okay, we can even derive this expression further. If we are going to put the expression of drift velocity, that is E tau by m, in place of Vd, then we'll get mu is equal to E tau m E tau upon me. So finally, after cancelling out E, we'll get mu is equal to E tau by m, where E is charge, tau is average relaxation time, and m is mass of the electron, while mu is the current mobility. Now from the expression it is very clear that current mobility is actually directly proportional to relaxation time. Okay, so mobility depends, or current mobility depends only on relaxation time. Now the next topic is current density. So current density is first of all denoted by J, and the expression for J is I upon A. So we can define that current density is current upon area. Okay, now first of all, how to memorize this expression? So like for example, in general, density means mass upon volume. For energy density, it is energy upon volume. For charge density, it is charge upon volume, and if it is current density, so it should be current upon volume. But here we measure the current as per the area of cross section. Hence it would be defined as J is equal to I upon A. Now what is this I? So the expression for I we have already derived in terms of drift velocity, that is NEA Vd, which I have written over here. And if we put this formula in the expression, finally we'll get J is equal to NEA Vd upon A, where A and A would get cancelled out, and we are left with J is equal to NE Vd. Next is Ohm's law. What is Ohm's law? This is something which we have already done in class 10, so we already know what is Ohm's law, but we will still study a little bit about it, that what exactly this Ohm's law is all about. So Ohm's law states that keeping the physical conditions constant, the current flowing in a conductor is directly proportional to the potential difference across the ends of the conductor. This is the definition which we have studied in our previous classes. Now, as per that definition, we can write V is directly proportional to I. But if we remove this proportionality sign and if we'll put an equal to sign, then we'll have to put a constant, and the constant is R, where R we already know that R is resistance of the wire. Okay, so if we'll keep R as the subject, then R would be equal to V upon I, or V upon I is equal to constant, as R is a constant. Okay, now let us discuss more about resistance. So resistance is actually the obstruction offered to the flow of current. Okay, so what is the obstruction that is caused to the flow of current? Actually, a wire consists of many electrons, and when an electron tries to move to develop current, there are many other electrons which come into its way. So this electron collides with other electrons, and it becomes very difficult for the electron to move from one place to another smoothly. Hence these collisions are a kind of obstruction which is being offered to the electron, because of which the electron faces difficulties in moving from one place to another, and this is the obstruction which is being caused in the flow of current. Okay, so if in case anybody asks you that what is the source of resistance, we can clearly say that the collisions of the electrons are actually the source of resistance. Okay, what is the effect of resistance now? So the effect of resistance is heating effect. Whenever there would be collision of electrons, whenever there would be resistance in the wire, obviously the wire would get heated up. So this is also known as Joule's heat, which we have studied in class 10th. So whenever there is resistance in the wire, whenever current is flown in the wire, due to these collisions, heat is produced in the wire. And we have one application also for this heating effect of resistance, which is known as electric heater, which we have studied again in previous classes. Okay, now let us talk about the factors on which resistance depends. Okay, so resistance R is actually directly proportional to length. Longer, the more the length of the wire, the more is the resistance in the wire. Okay, and the second factor is area of cross section. So resistance is actually inversely proportional to area of cross section. See it in simple words, we can say that if we are driving a vehicle on a road, okay, and that road is very wide, चौड़ी रोड है, नैरो नहीं है, there are many vehicles on the road, but still we will be able to cross the road very easily without any collision, because we have enough space. Similarly, in a wire, if the wire is very broad, then there would be enough space for the electron to move about easily or freely, okay, without collisions or minimum number of collisions. So hence, if the area of cross section of the wire is more, so the resistance would be less. Hence resistance is inversely proportional to area of cross section. And if we combine both the factors, we will get R is proportional to L upon A. If we remove this proportionality sign, and if we put an equal to sign over there, we will get a constant also. This constant is rho, and rho is also known as resistivity or specific resistance. Okay, the SI unit of resistance we already know, it is ohm.